Okay, dear students, so today we are going to do a resonance. Okay, so what is a resonance? When molecules cannot be represented by a single structure. When any molecules we cannot represent by a single structure. Why? Because that single structure, it may not be able to explain all the properties of that. So when a molecule cannot be represented by a single structures, but its characteristic properties can be described, but the characteristic property of that particular molecules can be described by two or more than two structures, then the actual structure will be called as what? Resonance hybrid of the other structures. Got it or not? So that means what? And what does it, this arrow means? Why we are drawing this arrow? This arrow indicates this structure as well as this structure. Both the structure, they are contributing to the resonance hybrid. That's why we draw this arrow, double arrowhead. Okay, and this one is the most stable structures here. Okay or not? Got it? See, resonance ka need has arisen when we came to know that some molecules are there which cannot, in which single Lewis dot structure cannot indicates all the, or cannot describes all the property. There the needs of resonances comes, and resonance, remember, this is a hypothetical assumptions. Okay or not? Next, resonance energy, the difference between the energy of the molecules. Okay, the difference between the energy of actual molecules and the energy of the most stable structure is called as what? Resonance energy. Got it, dear students? So pause the video, take down the notes. Bond order. Okay, calculation of bond order in resonating structure. Okay, resonating structure, very important topic it is. So the students, try to learn it properly, not only for your board examinations and all, it is very important for your competitive exams as well. So calculation of bond order in resonating structure. So how we will be calculating this? So the formula for this is what? Bond order. Okay, bond order equals to total number of, okay, total number of bonds between, total number of bonds between two atoms. Okay, total number of bonds between two atoms in all the structure. Total number of bonds between two atoms in all structure by total number of resonating structure. Total number of resonating structure. Okay, resonating structure. Total number of resonating structure. Got it? So calculation of bond order in resonating structure. Bond order equals to total number of bonds between the two atoms in a structure by total number of resonating structure. Okay, so let's try to calculate it. This questions is very easy, very simple. Let us try to understand, okay, properly. First, let's assume, okay, let's assume first, for example, let us try to calculate with the carbonate, CO3 to negative. If you draw the resonating structure of carbonate, it comes to like this: C O O O O O, and here it will be double bond, then 4 electrons will be here. Here it will be 6 electrons, and here also it will be 6 electrons, right? If I draw the resonating structure of this carbonate, then what will happen? The double bonds will be shifting one by one. Okay, so you will get the double bond here. Now double bond is here, then 1 2 3 4. Here it will be single bond, 1 2 3 4 5 6, and here it will be 1 2 3 4 5 6. This is one. Again, another one resonating structure is there. How it will be? C single bond, 2 lone pair of electrons here, and then here it will be double bond, 2 lone pair of electrons will be here. Sorry, it will be 4 only, and here it will be how much? 6. So 6 electrons are there. So this is the resonating structure of carbonate. Now let us try to calculate the bond order of carbonate. Okay, so bond order of carbonate, okay, is equals to what? Total number of bonds between two atoms in a structure. So between two atoms in a structure, if you see total number of bonds, then how many are there? For double bond we will be writing 2. Okay, so here one double bond is there, so we'll write 2, and plus here 1 and 1, so 1 plus 1. So total number of bonds is how much? 1 2 3 4. You can write directly 4 also, no problem. Okay, so total number of bonds in the structure, everywhere it is 4, so you have written 4. Now what is the number of resonating structure? 1 2 3, so divided by 3, so you will be getting how much? 4 by 3, and 4 divided by 3, it will come how much? 1 point, so 1.3. okay, it will be coming out 1.33 something. Okay, yeah, so bond order here it will be 1.33. so dear student, one thing I want to tell to all of you, that first of all we can know in advance where will be the bond order line. We have to count out, we have to see which bond is more. Here you can see 2 sigma bonds is there, single bond is 2 and pi bond is only 1. So that means for pi bond, single bond, bond order is 1. For 2 sigma bond, pi bond, bond order is 2. So which one is more? The bond order, the number of single bond is more, so that means the bond order will lie in between these two. Okay, which will be more closer towards 1. Okay, got it, dear students? So this one you have to take it, keep it in mind. So this is how we calculate the bond order of the resonating structures. Okay, so this concept is very important. Try to learn some more on these concepts. Okay, take some more examples of resonating structure and try to draw the find out their bond order. So you can take it down, then we shall switch on to the next topic. Okay, let us try to do one more questions on bond order. So we are going to calculate the bond order of these ions now. Okay, so these ions, it has 2 resonating structure, 1 2. Okay, so now what is the formula we have learned? Bond order equals to how to calculate the bond order? Total number of, again I am writing the formula, total number of bonds between the 2 atoms. Okay, between the 2 atoms, total number of bonds between the 2 atoms by what will be total number of resonating structure, number of resonating structure. Okay, resonating structures. So total number of bonds between the 2 atoms. So you see here, what is the total number of bonds? Here double bond 1 is there. For double bond we are writing 2. Okay, and for single bond 1. So double bond is how much? 2. Here double bond is there, 1 double bond, so 2, and single bond is 1, so 1. So what is the total number of structure? 1 2. It has only 2 structure, right? So divide by 2, so it comes to 3 divided by 2, which is equals to 1.5. So the bond order of NO2 negative is how much? 5. I hope, dear students, you have understood the concepts of how to find out the bond order of a resonating structures. Okay, so pause the video and take down some more questions. Try solving it, try finding it out the bond order of the more compounds or more ions. Okay, next we are going to discuss now. Okay, so the next topic we are going to discuss now, the next topic which we are going to discuss now is polar covalent bond. Okay, what is polar covalent bond? Okay, polar covalent bond. Let us first learn this one, then we will learn about polarity. Okay, so what is polar covalent bonds? So polar covalent bonds, the covalent bond, okay, covalent bond which is formed between two unlike, okay, the covalent bond which is formed between two unlike atoms two unlike atoms which differs, okay, which differs in electronegativity, ELECTRO negativity, which differs in electronegativity are called polar covalent bond. Polar covalent bond. Got it? So polar covalent bond is what? The covalent bond which is formed between two unlike atoms which differs in electronegativity are called as what? Polar covalent bond. For example, let's take an example of let us take an example of HCl. Okay, so you can take we can take an example of what? HCl. So in examples you can write HCl. So you can say that H, it has only 1 electrons, okay, and Cl, it has how many electrons? 7 electrons it has, okay. The electronegativity of both these atoms are far away from each other. Hydrogen electronegativity means capability to attract electron is very less, whereas the electronegativity of the electronegativity of chlorine is very high to pull the electrons, okay. So the bonds which they will be forming in between them, okay, that bonds, it will be nothing but this bond, we will be calling it as what? Polar covalent bond, okay. And polar covalent bond, we represent it in this way. Got it? So this is called as polar covalent bond. Got it? So here the polar covalent bonds and these compounds, this bond we call it as a polar covalent bond. Why? The arrowhead will be pointed towards the one which is gaining the electrons, and the tail will be towards the one which is donating or giving away the electrons, okay. So this is polar covalent bond, and this compound, okay, the compound will be what? HCl. So this compound as a whole, the compound as a whole will be called as what? The compound as a whole will be called as polar compound, okay. This one you have to remember it, what? Polar compounds. Got it? Okay, so we have understood what is polar covalent bonds. So polar covalent bonds are the bonds which is formed between the two unlike atoms. The two are also unlike atoms, okay. Their electronegativity is very much different from each other's. The one which one will be more electronegative, they will attract the electrons towards itself, okay, and as a result the hydrogens will get partially positive charge and the chlorine will get partially negative charge, okay. So the electrons will be taken away by the chlorine. So the bond which they form, it's called polar covalent bond, and the compound as a whole will be known as what? Polar compounds. Clear? Understood this one? This point is clear. Now we are going to discuss what is the cause of polarity in a bonds, okay. Cause of polarity. So cause of polarity in a bond. So what is the cause of polarity in a bond? Why the polarity occurs in a bond, or why the polarity takes place in a bond? So the one reasons for the main cause of polarity in a bond is the differences in electronegativity. Differences in electronegativity between the bonding atoms. So what is the main cause of polarity? The main cause of polarity in a bonded in the bond is the main cause of polarity. Okay, the main cause of polarity in the bonded atoms is the difference in electronegativity between the bonding atoms. The difference between them, the electronegativity difference between them is the cause of polarity in the polar compounds. Got it or not? So this point is clear. Okay, so if you are asked why does the polarity occurs between two atoms, so the main cause of polarity between the two atoms is what? The difference in their electronegativity. Okay, dear students, I hope you have understood. Okay. Now the unit to measure the polarities, the how we are measuring the polarity, a measurement of degree of polarity. So how to measure the polarity? Okay, measurement for polarity we are going to discuss now. How to measure it? All of you can pause the video and take down the notes. Okay, so we have understood what is polarity, polar covalent bond, what is the cause of polarity. Now we are going to discuss how to measure the polarity. So okay, the unit of okay the polarity, the measurement of polarity, the polarity is measured in form of dipole moment. Dipole moment. Polarity is measured in form of what? Dipole moment, and dipole moment is represented by this way. Okay, this arrowhead. We have represented a polar covalent bond, that is nothing but dipole moment. Okay, so dipoles, it is represented as this way. Okay, arrowhead and the plus signs. So now you see dipole moment. Okay, now what is dipole moment? First of all, we should know what is dipole moment. So dipole moment is defined as the product of dipole moment, it is defined as the product of charge and the difference and the distance of separation between the charge and distance of separations between the charge. Okay, so dipole moment, basically we the symbol for dipole moment is D. Okay, got it? The symbol for dipole moment, we are using it as what? Mu. The symbol of dipole moment is mu. Mu is equals to charge, any of the charge, into distance of separations between the charge. Okay, so dipole moment is represented by a symbol mu. Dipole moment is represented by a symbol mu. Mu is equals to Q into D. Okay, and the unit of dipole moment is, dipole moment. Okay, dipole moment is, the unit of dipole moment will be what? Diopter. Okay, the unit of dipole moment is diopter. Okay, okay, or we call it as d by, sorry, the unit of dipole moment, we will be writing it as d by. Okay, so this will be the unit of dipole moment. Got it? So today we have learned what is polar covalent bond, what is the cause of polarity. Then we have learned how we measure polarity. The polarity is measured in form of dipole moment. And what is dipole moment? Dipole moment is defined as the product of charges and the distance of separations between the charge. And dipole moment symbol is what? Mu. Mu is equals to what? Product of magnitude of charge into distance. Okay, and the unit of dipole moment is what? Dby. Got it? So these are the things related to the dipole moment and polarities. Okay, got it, dear students? Okay, so you can pause the video and take down the notes. Okay, so hope you have written about dipole moments and all. Now we are going to see what are the importance of polarity. Okay, what are the importance of polarity? Those things we will be seeing point by point. Okay, so our next heading is importance of dipole moment. Importance of dipole moment. Okay, so importance of dipole moment, the first point is what? It helps in distinguishing between polar and non-polar substance. Polar and non-polar. Okay, dipole moment, it helps in distinguishing the polar and non-polar molecules. Okay, molecules. Suppose one molecule is there whose polarity is, suppose let it be any molecules. Suppose two molecules are there. One molecule's polarity mu equals to 0, another polarity is mu equals to 1.5. So which one is more polar? This one is more polar. So this one will be considered as polar and this one will be considered as non-polar. Okay or not? So it helps us in distinguishing between polar and non-polar molecules. The first importance of dipole moment. Second, degree of polarity in the molecules. Okay, it helps or it tells us about the degree of polarity in a molecules. Okay, it tells us about the degree of polarity in a molecules. Okay, got it or not? So that is the importance of it. For examples, okay, for examples, you see here HF. The dipole moment of HF is 1. Let's assume 1.78 dby. Okay, the dipole moment of HF is 1.78 dby, and the dipole moment of HCl equals to 1.07. Okay, 1.07 d. So which one is more polar? Of course, here the polarity is here, that dipole moment here is high, so polarity also will be high. So dipole moment tells us about the degree of polarity of a compound. So this one will be more polar. Got understood? Because the polarity dipole moment is high. Okay, understood? So third point is what is the importance of it? It tells us about the shape of the molecules. Okay, so it gives the shape of the molecule. It gives the shape of the molecules. Okay, got it? So it is giving us what? It is telling us about the shape of the molecules. Next one, it tells us about the ionic character of the molecules. Fourth one is ionic characters of the molecules. Ionic characters of the molecules. Character of molecules. Okay, so it gives us the information about the ionic character of the molecules. The fifth point and very important point is it helps in distinguishing between cis and trans. Okay, it helps us in distinguishing between cis and trans isomers. Got it, dear students? So these are the importance of what? Dipole moment. Dipole moment helps us in distinguishing whether the substances is polar or non-polar. Next, it helps us in telling the degree of polarity. If the value of dipole moment is high, the degree of polarity is high. Okay, it helps us in telling about the shape of the molecules. It tells us about the ionic character of the particular molecules. Then finally, it helps us in distinguishing between the cis and trans type of molecules. It is between to distinguish between this. It tells us, okay, between the cis and trans. Okay, so that is the end of this dipole moment topic. Now, dear students, in the next class we will be doing the Fagans rules, and then 5-mark questions are there. There are 3 topics which contains each 5 marks for your board examinations, and it's very important. So we'll be discussing it in the next class, and don't forget to watch that videos, and definitely these videos as well. So don't forget to watch it, and if you need any help in getting regarding this series, regarding this chapter's lectures, please feel free to give a comments in the comment box. And dear students, if you are new to the channel, don't forget to subscribe the channel, because your subscriptions will encourage me to do better and upload more videos. Thank you.